You have already seen my first video on Lissajous figures, in which the two simple harmonic oscillations acting at right angle have actually equal frequencies. Okay. In the same way, today we are going to discuss the problem of Lissajous figure again, but in this case we are going to see what type of Lissajous figures will be observed when the two oscillations acting at right angle will be of different frequencies. Okay. So actually here in this case our aim is to discuss the composition or the superposition and finding the resulting motion of a particle which is acted upon by the two SHMs at right angles having different frequencies. Again, you can think that there may be different choices of taking the different frequencies. Here again I am choosing a very simple case. In first problem we will consider that the ratio of the frequencies of two SHMs is 1:2. It means if you consider that the frequency of first SHM is omega, then the frequency of the second SHM will be 2 omega. Okay. So in this particular condition, what resulting path will be traced out by the particle which is acted upon by such two simple harmonic motions acting at right angle? Because you know, when the frequencies of the two perpendicular SHMs which are not equal, and then the resulting motion becomes more complicated. The first case, when you have considered that the two SHMs have equal frequency, that was a simple case. But when you will take that the frequencies of two superposing SHMs are not equal, the mathematical calculation will become something complicated. And the pattern, that is Lissajous pattern, will be also somewhat complicated. So again in this case we are thinking about a simple case, which I have told you that we will discuss here the composition of two simple harmonic motions acting at right angle having frequency in the ratio 1:2. Okay. Actually again I am telling you that this problem is dealt by two methods. First one is called analytical method, another is called graphical method. Again here we are going to see the analytical method to solve this problem. And for this let us consider there is a particle which is acted upon by two simple harmonic motions of different amplitude and phase, and their frequencies are in the ratio 1:2. It means if you consider that the first SHM is along x-axis and its frequency is omega, the SHM which is along x-axis, the frequency of such SHM is omega. Then the another SHM you may take along y-axis so that they will be perpendicular to one another, and then you have to take the frequency of the SHM along y-axis as 2 omega. Then the ratio of the frequencies of these two SHM will be 1:2. So you can represent these two SHMs in this manner: x equal to a sine omega t and y equal to b sine 2 omega t plus phi. You can see here the frequency of the SHM on y-axis is 2 omega, while the frequency of the first SHM along x-axis is omega. Okay. And here phi is the phase constant of the second SHM, and I have considered here for simplicity the phase constant of the first SHM is 0. So you can also say that this phi is actually the phase difference between these two SHMs. Okay. Now, as I have told you that the Lissajous figure or the pattern or curve can be obtained either by analytical method or graphical method. And in this video, we are going to see only the analytical method. Okay. When you talk about analytical method, actually what we find? In fact, in analytical method, we find the locus of the instantaneous particle positions by eliminating time t from these two equations 1 and 2. Because our aim is to find the equation of trajectory. And you know, equation of trajectory is nothing. This is simply the relation of x and y. That is finding y as a function of x. That very equation represents the equation of trajectory. But here, in equation 1 and 2, both x and y are related to a variable t, which is time variable. So if your aim is to find the resulting trajectory or equation of resulting motion trajectory, you must eliminate this t, and for that you have to think about some algebra so that t will be eliminated. This is actually very simple, as we have seen in my previous video. Okay. And for this, let us expand this RHS of or this sine function of equation 2. You can see equation 2 is y over b equal to sine of 2 omega t plus phi. Now, applying the formula for sine a plus b, you can write for sine 2 omega t plus phi as sine 2 omega t times cos phi plus cos 2 omega t times sine phi. Okay. Again, you know, sine 2 theta, that is equal to 2 sine theta into cos theta. So, sine 2 omega t is equal to 2 sine omega t times cos omega t. Okay. And cos phi is attached. Now, again, you know, this cos 2 omega t is equal to 1 minus 2 sine square omega t. So, for cos 2 omega t, I have written here 1 minus 2 sine square omega t, and sine phi is attached. As I have told you, for finding the equation of trajectory, our aim is to eliminate the variable t. So you must eliminate this sine omega t, cos omega t, and this sine square omega t from this equation 3 for getting equation of trajectory. And that can be easily found by the use of the equation of the first SHM, which is x equal to a sine omega t. You can see, since x is a sine omega t, so sine omega t will be equal to x over a. And so cos omega t will be equal to a square root of 1 minus x square over a square. Okay. So you can see, I have found the value of sine omega t and cos omega t in terms of the variable x. So if you will substitute the values of sine omega t and cos omega t in this equation 3, then this equation 3 will become free from the variable t, and we will get a relation between the two coordinates x and y, which is called equation of trajectory. So let us substitute the values of sine omega t and cos omega t in this equation 3. Okay. So you can see, now this equation 3 becomes y over b equal to 2 times sine omega t, but sine omega t is x over a, so this is 2 times of x over a, times cos omega t, but you can see cos omega t is a square root of this much. So this is a square root of 1 minus x square over a square. And cos phi is attached here. Again, in the second term, there is 1 minus 2 sine square omega t. So this will be actually 1 minus, and sine phi is multiplied here. So let us multiply by this sine phi to these two terms. So the first term will be sine phi, and second term will be 2 sine square omega t times sine phi. This 2 sine phi is at each, and at the place of sine square omega t, you may write x square over a square. Okay? Now, to cast this equation in a convenient form, let us bring these last two terms in LHS. And bringing these two terms, you can see this will be y over b minus sine phi plus 2x square over a square times sine phi. And that will be equal to 2 times of x over a times a square root of 1 minus x square over a times cos phi. Okay. Now, to get rid of this square root, let us square this equation both sides. Okay. So you can see after squaring, what will be our result? This will be y over b minus sine phi whole square plus 4x4 over a4 times sine square phi plus 4x square over a square times sine phi times y over b minus sine phi. We have actually used the formula for the expansion of a plus b whole square. And in RHS, you can see this will be 4 times x square over a square times 1 minus x square over a square times cos square phi. So I have written it here, you can see. Now this RHS can be written as 4x square over a square times cos square phi minus 4x4 over a4 times cos square phi. Okay. Now this can be simplified as y over b minus sine phi whole square plus. Now see this term which I am underlying here. This is actually 4x square times y over a square times b times this sine phi. So I have written it here, you can see. And when you will multiply by this factor 4x square over a square times sine phi to this sine phi, your term will be minus 4x square over a square times sine square phi. Okay? And then I have written this second term here, 4x4 over a4 times sine square phi. And RHS is at each. Now, bring these two terms in RHS in LHS and combine these two terms with the suitable terms. You can see the first term I have written here, which is at each. Okay. The second term is also at each, you can see. And combine the term 4x square over a square times cos square phi and 4x square over a square times sine square phi. You may take minus 4x square over a square as a common factor. And after taking this as a common factor, the remaining terms will be sine square phi plus cos square phi, which will be equal to 1. Okay? And again, now combine these two terms, that is 4x4 over a4 sine square phi and 4x4 a4 cos square phi. Here again you can take this 4x4 over a4 as a common factor, and the remaining terms will be sine square phi plus cos square phi, which will be 1. So taking this sine square phi plus cos square phi equal to 1, our result becomes y over b minus sine phi whole square plus 4x square y over a square b times sine phi minus 4x square over a square plus 4x4 over a4. that is equal to 0. Okay. Actually, this is the resulting equation of motion of the particle. Or you can say this is the equation of the trajectory, equation of the path described by the particle which has been acted upon by two simple harmonic motions of different amplitudes A and B and different frequencies omega and 2 omega. Okay, this is the equation of trajectory. Or you can say this when the particle will move in this xy plane, the path generated by the particle will be governed by this equation. Okay. You can see that actually this equation is of fourth degree. Here highest power on x is 4 and therefore you can say that this equation is of fourth degree. Okay. Actually this fourth degree equation in general represents a closed curve having two loops like this. Like this. This equation represents a closed curve and it has actually two loops. Okay. Actually the actual nature of the path will be decided by this phase difference phi between the two SHMs. So here we are now going to see some of the particular cases where we will take some particular value of phi. Okay. So let us see. First of all, we are going to take phi equal to 0. When you say phi equal to 0, it means that the phase constant of the second SHM is also taken 0. Okay. Now, when phi will be 0, then what will be the equation of trajectory? For this, you can see when you will take phi equal to 0, sin phi will be 0. So, this equation A now becomes what? For this, you have to take sin phi equal to 0 in both of these two terms. So, after taking sin phi equal to 0, our equation A will become what? This will be, you can see, y square over b square plus. This term will vanish because here sin phi is present and sin phi is 0. So the first term will be y square over b square and these last two terms will remain at each. Okay, in this condition. So you can see in this condition, the equation of trajectory becomes y square over b square minus 4x square over a square plus 4x4 over a4 equal to 0. Okay. We can simplify this equation a little bit. The first term is at it is y square over b square. And in the last two terms, let us take this 4x square over a square as a common factor. Then the remaining terms will be x square over a square minus 1 and that is equal to 0. So this is the result, this is the equation of path or equation of trajectory when phi is equal to 0. Mark here, phi is not phase difference between the two SHMs because at time t, the phase of first SHM is omega t and that of the second SHM, this is 2 omega t plus phi. So, when phi is 0, the phase of second SHM is 2 omega t and that of first is omega t. So, you can't say here that phi is the phase difference between two SHM. You can't say. Phase difference will be actually equal to 2 omega t plus phi minus omega t. That is omega t plus phi will be the phase difference. Okay. And when you will take phi 0, this will be omega t. So omega t is here phase difference. But I have taken this phi equal to 0. And in this condition, the equation of trajectory becomes like this, which I have defined in this equation 1. Actually, when you get such an equation, So this equation represents what type of curve? For this, you have must a concrete knowledge of coordinate geometry. Actually, when you study coordinate geometry for different curves, then you find that this equation 1 represents a closed curve having two loops, as you can see in this figure. In this figure, I have shown a closed curve having two loops, and it is inside a rectangle whose sides are 2a and 2b. Okay. So when phi will be 0, then the Lissajous figure will be like this. This is actually the Lissajous figure. Okay. The particle will describe such a curve. You can see this will be the path traced out by the particle. Okay, you can see. Now, we are going to see another standard value of phi, which is pi by 2. You know, if phi is pi by 2, then sin phi will be 1. So in this condition, what will be the equation of trajectory? For this, we will again substitute the value of sin phi, which is 1 in this case, in this equation A. So instead of sin phi in first term and in second term, we will put 1. So see this equation A and write again this equation taking sin phi equal to 1. Okay. And you can see in this condition, actually, when we will take sin phi equal to 1, our equation becomes y over b minus 1 whole square plus 4x square times y over a square times b, and minus 4x square over a square plus 4x4 over a4 equal to 0. Now this second and third term, you can combine these two terms and you can write this equation as y over b minus 1 whole square plus 4x square over a square times y over b minus 1 and plus 4x4 over a4 equal to 0. Now you can see, if you take this y over b minus 1 equal to, let us say, x, okay, and this 2x square over a square as y, then this expression is actually x square plus 2xy plus y square, and this can be written as x plus y whole square. So taking y minus b minus 1 as x and 2x square over a square as y, we can write it as x plus y whole square. So this expression is written as whole square of y over b minus 1 plus 2x square a square, and that is equal to 0. Actually, this equation 2 represents two coincident parabolas with the vertices at point 0, b, as you can see in this figure. Here, this is one parabola, okay, and this is the second parabola, and both parabolas coincide with one another at this point, whose coordinates are 0, b. Okay. So when phi will be equal to pi by 2, then the Lissajous figure will be just like as shown in this figure. That will be two coincident parabolas, as you can see in this figure. And what will be the equation of those parabolas? You can easily obtain. Since this much is equal to 0, so you can write that y over b minus 1 plus 2x square over a square is also equal to 0. And therefore, you can write that y over b is equal to 1 minus 2x square over a square. Okay. Or after taking LCM, you may write like this. This is a square minus 2x square over a square. And therefore, y is equal to minus b over a square times 2x square minus a square. Actually, this is the equation of each parabola. This first parabola will be represented by this equation. This second parabola, this will be also represented by this equation too. Okay. So this such Lissajous figures is found when phi is equal to pi by 2. So in this way you can see that taking the different values of phi, like phi equal to pi by 4, phi equal to 3 pi by 4, phi equal to pi, and so on. You may obtain the equation of trajectory, and with the help of knowledge of coordinate geometry, you can decide what type of curve, what type of figure we will obtain. Okay. Actually, I have not done those things here, and also there is no need for deriving the result for all the possible values of phi. But for your examination purpose, I have actually sketched here some figures for different values of phi. So you can remember these things for your examination purpose. If you have to write the answer in your examination, there is no need to write equation of trajectory for all values of phi. Okay. We have written the particular expression for equation of trajectory for phi equal to 0 and phi equal to pi by 2. That is more than sufficient. Okay. But remember these figures. When phi is 0, you have already seen, in this case the Lissajous figure is a closed curve having two loops, as you can see in this first figure. When phi is pi by 4, then Lissajous figure is like this. And you have also seen just now that when phi is pi by 2, then the Lissajous figure is a parabola, which is actually the combination of two parabolas, okay, or two coincident parabola. When phi is 3 pi by 4, then again the Lissajous figure is same as that in case of phi equal to pi by 4. Okay. And for phi equal to pi, again the Lissajous figure is same, but the sense of rotation of the particle, when phi equal to 0, the sense of rotation of the particle will be anti-clockwise, and in this case the sense will be just opposite. Okay, in this case, like this. Again, at phi equal to 2 pi, situation is just as you can say in case of phi equal to 0. Okay, no difference between phi equal to 0 and phi equal to 2 pi. And for phi equal to 5 pi by 4, just the reverse figure you will obtain as you have obtained in case of pi equal to pi by 4 or 3 pi by 4. Okay, as you can see in here. And for phi equal to 3 pi by 2, again we will have a two coincident parabola, but in this case the vertex of the parabola will be at just opposite point, that is at a point whose coordinates will be 0 minus b. Okay, here you will take the origin. So in this way I have just drawn some of the figures, but I have not calculated and not obtained the particular equation of trajectory for those values of phi, and there is no need for it. So I hope you have clearly understand the discussion of today's video, and definitely you have find it interesting, and for your examination purpose this is very important. So go through the video seriously and write down these things in your notebook, and definitely you will get good marks in your examination. Okay, thank you very much.